Science has research programs. So far we have been trying to solve the demarcation problem, which is a seemingly simple question. What makes science special? What is the difference between science and other things? We have already looked at and discarded 5 answers. The most recent answer was Kuhn's idea that what makes science special is that it's a puzzle-solving activity. For Kuhn, a practice is scientific if it aims to solve a puzzle premised on a paradigm shared by its practitioners. Today we will examine the ideas of the Hungarian philosopher Imre Lakatos. Just like Kuhn, Lakatos also rejects the idea that scientific theories are statements. In Lakatos's view, scientific theories are structures, which he calls research programs. Research programs are very similar to Kuhn's paradigms, but with one crucial difference. Research programs have a hierarchical structure. Each research program consists of 2 parts. The first part is an all-important, indispensable hardcore. The second part is a disposable protective belt. Let's start with the hardcore. The hardcore is a set of concepts, claims, or commitments that define a scientific theory. They are so essential that if you give up on any of them, you would be giving up on the theory itself. For instance, the hardcore of Newtonian physics is Newton's 3 laws of motion and the law of universal gravitation. One cannot be a Newtonian physicist if they reject either one of these. Or take evolutionary biology. At its hardcore, you will find 3 commitments. All life on Earth has common ancestry. All organisms descended from this common ancestor with random modifications to its genetic information, which we call mutations. And these random modifications were subjected to natural selection. The fit survived and proliferated, and the unfit perished. If a biologist were to deny any of these 3 claims, they would be denying the theory of evolution itself. And finally, consider Marxism, a political theory. At its core, Marxism has 2 premises. All social problems can be reduced to class struggle, which means a society that can eliminate class struggle will also eliminate all social problems. What's more, societies inevitably evolve from feudalism to capitalism, then to socialism, and finally communism. If you deny either one of these 2 claims, you are not a Marxist. Then there is the protective belt, which is a collection of concepts, methods, and commitments that surround the hardcore but aren't essential to the theory. For instance, when conducting experiments, Newtonian physicists make a bunch of assumptions. They rely on optical principles that are not part of the hardcore. They use instruments such as telescopes and information contained in astronomical records. Here's a personal example. When I was a physics student decades ago, we were doing an experiment to use Newton's 3 laws to calculate Earth's gravitational acceleration. We were basically dropping an object from a certain height and measuring the time it takes for that object to reach the ground, and using that time to compute the Earth's gravitational acceleration. I knew that the correct answer to that question would be 9.8. But when I ran the experiment and crunched the numbers, I got 7.3, not 9.8. Of course, I knew why I didn't get the correct value. It was because of air resistance. The assumption air resistance may slow down objects is part of the protective belt of Newtonian physics. Even when an experiment fails to produce the right result, you can use that assumption to protect the hardcore from being falsified. Of course, I said in my lab report, well, the laws of motion are still correct. I just didn't take air resistance into account. Similarly, evolutionary biologists also use a protective belt to shield the hardcore of their theory from falsification. They make assumptions about anatomical similarity, they rely on genetic analyses and paleontological records, they use radiological dating to determine how old a sample is. For instance, evolutionary biologists J.B.S. Haldane famously claimed that all it would take to falsify the theory of evolution is rabbit bones found in the Precambrian rock formations. However, a single set of bones would not prove anything. After all, an evolutionary biologist could easily claim that the rock formations must have been dated incorrectly, or there must be some error in the classifications of those bones as rabbit bones, or they must have been planted in the dig site by a prankster. They wouldn't give up on the hardcore so easily. First, they would throw parts of the protective belt under the bus. Similarly, Marxists also rely on auxiliary hypotheses when they try to make sense of the world. They often assume, for instance, that capitalists unite against socialists to stop or reverse the inevitable progress towards communism. They often express suspicion about the loyalty of individuals and groups because people are, after all, selfish and greedy, and they can sabotage a socialist society from within. Lakatos also thought that scientists in a research program exercise two kinds of heuristics, positive and negative. A heuristic, by the way, is a procedure that is not guaranteed to work but could work. For instance, if you keep experiencing connectivity issues at home, you would try resetting your router. That's a heuristic because it could fix the problem, but it also might not. A positive heuristic is creative or constructive. It aims to expand and refine the protective belt and generate novel predictions. Negative heuristics, on the other hand, is reactionary and defensive. It aims to make up explanations and excuses for failed predictions. Let's now think about how positive heuristics work in the context of Newtonian physics. As you might remember, Uranus's orbit was wonky. Newton's 4 laws predicted it to be slower than it actually was. Why isn't the prediction correct? Here, the Newtonian physicists did what anyone who supports the theory would do. They looked for an explanation that doesn't implicate the hardcore of Newtonian physics. They asked, what if our planetary database is incomplete? What if there is an unknown planet out there that is tugging on Uranus? They crunched their numbers using the 4 laws and calculated exactly where this unknown planet should be. And so they discovered Neptune. As you can see, not only these scientists managed to turn initial failure into a giant success, but also refine the protective belt in the process. Thanks to what their calculations showed, now we know that the solar system has 8 major planets, not 7. But sometimes things don't go as well, and scientists have to just keep making excuses by using negative heuristics only. Remember the story with Mercury, the planet closest to the Sun. Mercury also had a wonky orbit, which kept rotating around the Sun. Newtonian physicists tried the same trick that worked with Uranus. Assume that there must be an unknown planet out there that is tugging on Mercury. They named this hypothetical planet Vulcan after the Roman god of fire. But the trick, like restarting a router, doesn't always work. And it didn't work in this case. No matter how hard they looked for it, Newtonian astronomers couldn't find Vulcan. And they blamed the failure on the telescopic technology that was available to them. They thought Vulcan is so close to the Sun that it must be hiding in the Sun's glare. Of course, we know how that story ended. The problem wasn't the telescopic technology. It was the hard core. The law of universal gravitation yielded incorrect results when dealing with relativistic masses such as the Sun's. Vulcan didn't exist. The Sun pulled and stretched space itself. The truth, in this case, was stranger than fiction. Lakatos uses examples such as these to draw a distinction between two kinds of research programs, progressive and degenerating. When a program can successfully deploy positive heuristics to generate novel predictions and doesn't rely too much on negative heuristics, it's a progressive program. When a program fails to generate novel predictions and chronically relies on negative heuristics to make excuses, it's a degenerating program. Lakatos sees Marxism as a clearly degenerating program. Remember, Marxism has a hard core which consists of these two commitments. Because of the second commitment, Marx and Marxists expected the first socialist nation to be Germany. They predicted this because at that time Germany was the most industrialized country in the world, which Marxists see as a sign of being in the advanced stages of capitalism and on the verge of socialism. However, to their surprise, the first socialist government was founded in Russia in 1917. And 1970s Russia had by and large a primitive feudal economy. How did Marxists deal with their failed prediction about where socialism will first emerge? They made excuses. Falling back on the protector belt, they argued that the capitalists in Germany had united against socialism and temporarily stopped the progress of history in Germany. This led to increased pressure in Europe, which had to be relieved somewhere. And that somewhere ended up being the war-torn Imperial Russia. Of course, it is okay to make excuses like this every now and then. Just like me calculating the Earth's gravitational acceleration to be 7.3 doesn't disprove Newton's laws, one failed prediction of Karl Marx doesn't disprove Marxism. The problem with Marxists, Lakatos thinks, is making excuses is the only thing they could. To see why he thinks that, let's continue the story from where we left. The first socialist nation was the Soviet Union. Then there was the People's Republic of China. These societies claimed that they were on the path to cure all social problems by creating a classless society. However, the problems didn't go away. In fact, they grew and grew. Under the leadership of Stalin, for instance, more than 3 million Ukrainians died in a state-fabricated, man-made famine. This doesn't even come close to between 18 and 40 million deaths that happened under Mao's Great Leap Forward. Rather than solving problems, socialist states had made them worse, it seems. The reaction by those socialist states was to blame disloyal individuals and groups for the failure. Stalin established slave labor camps called gulags in which tens of millions of Soviet citizens who were suspected of disloyalty were worked to death at a gunpoint. Mao similarly blamed the reactionary agents in the Chinese society for his failed socialist programs. Under his watch, Maoist mobs and kangaroo courts murdered millions more, blaming the continued social problems on them rather than the hardcore of the Marxist ideology. But going back to philosophy of science, the important lessons to take home are these. No scientific statement can be tested in isolation. Every test targets an entire research program. A failed prediction doesn't falsify the entire theory. It can always be explained away with negative heuristics. Only progressive research programs, those that generate novel predictions, are scientific. Degenerating research programs such as Marxism are not scientific because they can't make novel predictions and they have to keep blaming the failure on the protector belt. Here, a program being progressive, as you can see, is the basis of scientific status. Lakatos's solution to the demarcation problem will lie here. But before we get there, let's examine the concept of a novel prediction a little bit more closely by studying another example. You might have heard of this expression, the theory of everything. In the early 19th century, Newtonian physics appeared to be the theory of everything. Newton's ideas dominated the scientific community. Scientists everywhere identified themselves as Newtonians and worked to prove Newton's predictions and refine and expand the protective belt of his theory. Newton even tried to explain light and visual perception with his 4 equations. Light, he thought, is a rain of tiny particles of different sizes. Your eyes are sensitive to different sizes of these particles, which they perceive as different colors. But not everyone was sold. A young French mathematician named Augustin Jean Fresnel developed a mathematically sophisticated rival theory to Newton's theory of light. Fresnel thought life is a wave, not a rain of particles. Another French scientist and self-proclaimed Newtonian named Poisson noticed that Fresnel's theory leads to a ridiculous prediction. Here is the prediction. If you put a point light source in a dark room and suspend a round opaque disk in front of the light source, the shadow of the disk that is cast on the wall will not be uniform. At the very center of the shadow, there will be a bright spot, a Fresnel spot. Poisson shared this information with the legendary and perhaps the greatest Newtonian scientist Laplace, who, according to legend, laughed out loud when he heard the ridiculous prediction of the silly boy's theory. Still, being scientists, Laplace and Poisson decided that they should test Fresnel's theory by an experiment. They set up the dark room, brought in a candle, and suspended an opaque disk to cast a shadow on the wall. Lo and behold, there it was, the Fresnel spot. Seeing this, according to, again, the legend, Laplace almost fell over in shock and horror. The Fresnel spot was at the time a novel prediction, and Lakatos thinks that it is proof that Fresnel's theory is scientific. As you know, the demarcation problem is a simple question. What makes science special? What is the difference between science and other things? Lakatos' solution is this. Only progressive research programs are scientific. What makes science special is its ability to generate novel predictions. Lakatos also thinks that degenerating programs such as Marxist history are pseudosciences. These programs don't generate novel predictions. They only make excuses. Lakatos is likable for several reasons. First, he doesn't try to oversimplify science, which is a tendency, as we saw, among falsificationists and inductivists. Yet you can see Lakatos' views as a successful attempt to reform falsificationism. Popper thought, remember, that you just take a theory and test it with an experiment. If the theory fails the test, you dump the theory. Lakatos says not so fast. What scientists do and should do is combining the hardcore with a bunch of disposable assumptions, forming a protective belt. If a theory fails the test by making a false prediction, you don't dump the entire theory. You try to explain the failure by pinning it on the protective belt. But Lakatos says you can't do that indefinitely. The more you rely on excuses, the less scientific your theory becomes. Like Kuhn, Lakatos also shows historical awareness, and he provides insights about psychology and sociology of science. However, there are also problems. Like Kuhn, Lakatos is also often vague about the fundamentals. Words such as negative heuristic, positive heuristic, novel prediction are never clearly defined. The lack of clarity of novel prediction especially is problematic. What exactly makes a prediction novel? Lakatos never says. Here, there are 3 possibilities, at least I can think of, which aren't mutually exclusive. First, a prediction might be novel when it is not explicit in the theory's hardcore. This, however, can't be the standard because if it were the standard, pretty much every theory would be scientific. After all, no theory's hardcore explicitly contains a prediction like Neptune is over there, or socialist revolution will start this afternoon at 3:39. Every prediction is the result of some legwork between the hardcore and the protective belt. Or you might say, A novel prediction is unknown until its discovery. This standard is also not very convincing. Why should it matter whether the Fresnel spot was previously known or not? Would it matter if someone noticed it a minute before Fresnel wrote up his theory and didn't tell Fresnel? Or you might say a prediction is novel if it is a surprise. But surprise is an individually and culturally relative concept. Some claims are seen as more or less surprising by some people and cultures. For instance, I might think a restaurant tab of $99.99 is surprising. But when you think about it, it is just as likely as any other number in that vicinity. I just see it as surprising because of the decimal system our culture uses. If you use the binary system, zeros and ones, or a hexadecimal system that goes up to 16, the number in that system representing 99.99 would have looked very unremarkable. In other words, why should something that is relative to arbitrary facts of personality and culture be the basis of whether a theory is scientific or not? So the problem with clarity has bad consequences for Lakatos. It threatens to implicate his demarcation criterion of being arbitrary. Another problem is that, again like Kuhn, Lakatos's solution to the demarcation problem seems unworkable. Some areas of science don't lead to any novel predictions because we pretty much know everything there is to know. For instance, there is almost nothing you can do by using an optical ground-based telescope at this point, other than perhaps pointing it at random locations in the sky and hoping that something bizarre will come in your view by chance. The situation is even worse in inorganic chemistry. All possible inorganic compounds are pretty much discovered at this point either by doing it in a lab or in a computer, and there is very little refinement that can be done. Should we drop these advanced disciplines from science curriculums because they don't make novel predictions anymore? Or go to the other end of the spectrum and think about the areas of science where the reality is so complicated it is nearly impossible to make any novel predictions. Are we ready to declare all the theories in psychology, sociology, and economics as pseudosciences? Lakatos might be ready to die on that hill. Indeed, he is infamous for claiming that evolutionary biology is not a science because it can't make novel predictions. But I am not sure that most people will share his perspective. He seems to be throwing the baby with the bathwater here. Recap. We said that the demarcation problem is a simple question. What makes science special? What is the difference between science and other things? We looked at a sixth and mercifully final answer to that question, Lakatos's idea that science is about making novel predictions. Lakatos thinks that only progressive research programs, those that can make novel predictions, are scientific. Lakatos's views are interesting but ultimately don't seem to provide a solution to the demarcation problem. Of course, that's exactly where we began. As you might recall, Paul Feyerabend said that there is nothing special to science. It's just another ideology which shouldn't be taken too seriously. There is a story about the philosopher Bertrand Russell. Towards the end of his life, Russell was kind of a rock star, a global celebrity. Journalists would harass him daily to ask him all sorts of questions. The most popular question was by far, what is the meaning of life? Russell, who would usually be happy to answer questions, would refuse to say anything in response to this popular question. One day, a frustrated young journalist lashed out. He said, "Why don't you just answer the question, Mr. Russell?" And Russell replied, "Because you are asking the wrong question." The journalist, who was a bit flustered, asked sheepishly, "What should I be asking then?" And Russell responded without a hitch, "You should be asking, what is the meaning of life?" Like the journalist, We have a choice. We can keep asking the simple question, what makes science special, over and over again. We can keep looking for a solution to prove Feyerabend wrong. Or we can change tactics and think about the demarcation problem itself differently. Maybe the question doesn't admit an answer because it is the wrong question. This shameless cliffhanger brings me to the end of this lecture. Send me an email if you have any questions. Thank you for your patience, and I'll catch you next time.